See, I think I have sent one file which is a distribution table. Okay, in
Yes.
your WhatsApp group. Did you find this?
Yes, sir.
Yes,
Okay.
sir.
So,
Yes, sir.
if possible, after today's class, you better take a printout of this copy. It will be useful for doing problems.
Okay, sir.
Okay, sir.
Okay. So now we'll start second unit. So first unit we discussed about random variables and probability distributions. Okay, we understood that random variables are of two types. One is discrete, other one is continuous. And the distribution function, the probability distribution corresponding to discrete random variable is called probability mass function. And the probability distribution corresponding to the continuous random variable is called probability density function. And we have seen properties of this PMF and PDF for both continuous case as well as discrete case. And after that we have seen what is a cumulative distribution function, or simply call it as distribution function. And we did some problems based on these random variables and probability distributions. Okay, so that is a general topic on random variables and probability distributions. Now we are going to see special probability distributions in unit 2. Okay, there are so many special probability distributions. Some of the we are discussing only these special distributions in unit 2. One is called binomial distribution. One is binomial distribution, other one is Poisson distribution, third one normal distribution. These are the three important probability distributions. Other one is sampling distribution of means, which is actually part of statistics actually. Okay, so I think in intermediate you might have studied binomial distribution already. Am I right?
And Poisson distribution also.
Okay, you learnt binomial as well as Poisson distribution. Normal distribution you don't know.
Yes, sir.
Okay, okay. So because you know binomial distribution, we'll start with what you know, and then we'll see some more points on binomial distributions. Okay. So can anyone tell me what is a binomial distribution, or when to apply a binomial distribution? There are two questions. Okay. So what is a binomial distribution? In what situations we are going to apply binomial distribution? Okay. Can anyone tell what is a binomial distribution? See, one thing you remember in probability and statistics, whenever you are talking about distribution is based on what? Whether it is PMF or PDF, this distribution is depended on the random variable.
Random variable.
You remember the how you are defining the random variable, depending on the random variable only your probability distribution will be defined. Okay, so if you want to talk about binomial distribution, you should know about the corresponding random variable of the binomial distribution. We may call it as a binomial random variable. Okay, so what is the definition of a binomial random variable? Okay, so when this binomial random variable will come into picture? Anyone? Okay, so
Same probability of success for every given distribution.
what do you mean by success?
For example, if we take for every experiment, will have same probability of taking what we need.
Can you elaborate?
I don't remember more than this, sir.
Fine. Okay, so we'll start with the discussion on binomial distribution. So binomial distribution will come into picture whenever the experiment is a Bernoulli experiment. Whenever the experiment is a Bernoulli experiment, or whenever the process is a Bernoulli's process, we can define a binomial random variable, and correspondingly you can have a binomial distribution. Okay, so a random experiment can have several possible outcomes. Okay, outcome of a random experiment is not unique. It has two or more possible outcomes. Okay, so a particular case of random experiment is called Bernoulli's experiment, or you may call it as a Bernoulli process. Okay, so when do we call an experiment is a Bernoulli's experiment? Okay, in what situation we see it as a Bernoulli's process? Okay, so let us see. Okay, so side heading, all of you note down Bernoulli's process. Bernoulli's process or experiment. First important quality of this Bernoulli's experiment is the experiment has n repeated trials. N trials. The experiment has n trials. All the trials are independent. All the trials are independent. Okay. Each trial has only two possible outcomes. Called as success and failure. The probability of each success in each trial is constant. The probability of success in each trial is constant. So any experiment having these properties, is said to be a Bernoulli's experiment. The experiment should have n trials. All these trials are independent. You know what are independent trials? One trial does not affect the other trial. Okay, and each trial has only two possible outcomes called a success and a failure. The probability of success in each trial is constant, and it is denoted by P. Can you give an example of this Bernoulli's experiment? Can you think of an experiment having these qualities? If an experiment having tossing a coin. Tossing a coin.
Yes, sir. Yes, sir.
Tossing a coin. Tossing a coin itself is a Bernoulli experiment, or what?
Tossing a coin or getting a particular tail or head.
See, what is the first one? The experiment has n trials. How many times you are tossing the coin? Tossing a coin is one trial, right? So the experiment must be tossing a coin 10 times. Say you are tossing a coin 10 times. Okay. So what is n here? When I toss a coin 10 times, n is 10. How many trials are there in that experiment? 10 trials are there.
N trials.
Are these trials are independent or not? Yes. Whether the first
Yes.
trial affecting second trial, whether fourth trial is affected by third trial. No. So all these trials are independent.
Independent.
Each trial has only two possible outcomes: a success and a failure. So what do you mean by success? What do you mean by success? Its complement will be failure. So what is success? What do you mean by success? Somebody is earning 1 crore. Okay, if we are also earning 1 crore, is that our success? Or somebody went to US, okay, to pursue a better career. By seeing him, you also got that wish. Is that your success? Do you think that other person's success is achieving other person's success is your success?
No, sir.
So
No,
what do you mean by success?
Achieving something by ourselves.
Uh, is it something or
achieving our dreams.
Meeting all our goals.
Getting desired results.
okay, something desired result? Okay. In mathematics, okay, yeah, in this case, okay, success means whatever you want to get. If you are able to get it, that is success. If that is not happening, that is a failure. Whatever you want to get, not okay, whatever you are feeling that I want to get this. If you are able to get this, that is your success. Am I right? So in this case, if you are tossing a coin, suppose you want to get a head when you toss a coin. If you are getting head, that is your success. If head is not appearing, that is your failure. Suppose you are throwing a die. Suppose you are throwing a die. Okay, what do you mean by success? How many possible outcomes are there when you throw a die?
Six possible outcomes.
Six
Six
possibilities.
Why you are thinking six possible outcomes? If you say there are six possible outcomes, that means you want to get a integer from 1 to 6. If you want to get any integer from 1 to 6, then the possible outcomes will be 1 to 6. Or if you want to get an even number, how many possible outcomes will be there?
3.
3.
How many events will be there? Let us say. So instead of say
2 events.
outcomes, let me change it. Events. Okay. Okay. Now in this case, there are only two events. One is an event of getting an even number. Other one is the event of getting odd number.
Odd
Okay?
number.
If you get an event, if you get an even number, that is your success. If you're not getting an even number, that is your failure. Okay. Suppose you do not want to get 2 when you throw a die. Okay, you do not want to get 2. 2 should not appear. You have thrown a die. 2 did not appear. Therefore, that is your success. Its complement will be your failure.
Failure.
Is that if 2 appears, that is your failure. Is it okay? So if you are thinking of an experiment in terms of only 2 possible events, okay, and if you are wishing to happen only one event, okay, and that is called success. Whatever the event you want to happen, that is called success. Its complementary is going to be failure. Okay, so if you are thinking of an experiment like this, okay, and probability of each success must be constant. Okay, suppose when you throw a die, okay, if you don't want to get a 2, then what is its probability? You do not want to get 2. What is probability? 5 by 6.
5 by 6.
5
That
by
5 by 6 is constant for each trial. No, how many number of times you throw the die? That 5 by 6 is constant. Similarly, when you toss a coin 10 times, okay, getting head in each trial is 1 by 2. When the coin is fair coin. So the probability of success is constant in each trial. Okay. So such experiments are said to be Bernoulli's experiment. Okay. And for hospital, what is success? Getting a patient. Okay. If a person is infected, then he will go to hospital, right? So for hospital point of view, okay, for them more patients are getting more patients is their success. But for the patient point of view, okay, getting infected is its failure, right? So this success and failure again purely relative terms. Okay, it depends on the person's perception. Okay, so there is nothing like pure success, pure failure. Okay, it all depends on your view. Okay, whatever you want to achieve, whatever you want to get, if you are able to get that, that is your success. That is your success. Okay, so. Then, how do we define random variable in this Bernoulli's experiment? How do we define a random variable in this experiment? Okay, so my next definition is binomial random variable. Binomial random variable. So, how do we define this binomial random variable? Okay. So its definition is, you write down, all of you write down the definition. Okay. X equal to number of successes out of n trials in a Bernoulli experiment. Okay, the number of successes. Whenever you are defining the random variable as number of successes in the Bernoulli's experiment, that is said to be, that random variable is said to be the binomial random variable. Okay. Can you tell me the possible values of x? What are the possible values of x? What is the minimum value of x? What is the maximum value of x? There are n trials. Suppose you are tossing a coin 10 times. Okay, and success means getting a head. Success means getting a head in a trial. So what is the minimum number of heads you can get? What is the maximum number of heads you can get?
0 head.
0 heads, that means no head,
Maximum.
or 1 head, 2 heads, or at most 10 heads.
10 heads.
Yes.
That means what? So in a Bernoulli experiment, the number of successes varies from 0 to n.
0 to n.
You may not be successful. You may not have any success, or you may have every success. Okay. So x takes. Okay. So x takes the values from 0, 1, 2 up to how many? N.
Yeah.
So what kind of variable it is? Is it discrete random variable or continuous random variable?
Discrete.
Discrete, because it is only finitely, it is taking only finitely many values of values. So whenever x is taking only finitely many values, then that random variable has to be called as
Discrete random variable.
discrete random
Discrete
variable. So
random
write that as a note. Write that as a note. Okay. So x is a x takes values from 1 to n, and hence x is a discrete random variable. Whenever I write r dot v, you think that it is a random variable. Okay. So x is a discrete random variable. Okay. Now, how do you define the probability density function? Probability mass function. So what is f of x? F of x means what? Probability that x takes x number of successes. Probability that x takes x number of successes. In binomial distribution, we call it as binomial of x number of successes out of n trials with probability of each success equal to p. With probability of each success equal to p. Okay. So what will be the formula for it? Can you tell me? You can think of that good bad. Okay. Okay. So there are n possibilities. Okay. Success may appear here, success may appear here, and so on. Success may appear here. Okay. So totally n trials, 1, 2 up to n. Okay. So among n trials, okay, you want x trials to be successful. Which x trials? Suppose there are 10 trials are there. First 3 maybe you may be getting you may want 3 successes. 3 successes may be in the first 3 consecutive trials, or it may be 8, 9, 10, or it may be 5, 6, 7, or it may be 2, 9, 10. So these 3 successes can happen in among these n trials. No? So how many ways that can happen? NC,
NC3,
NCX,
NCX.
and you want exactly 3 successes. Okay, that means what? P into P, and remaining must be failures. Am I right? So that means what? P power x. Okay, because these trials are independent. P and means what? This and become product because the trials are independent. Am I right? So p power x into q power 1 minus x.
Minus
What is q?
1 minus P.
failure. 1 minus
Minus P. Q is failure.
Q is not failure. Q is probability of getting failure.
Fail.
Right? So where q write down? Where q is hello.
Yes, sir.
Yes. There is some problem writing the pad. Write down where q equal to 1 minus p, which is a probability of getting a failure. Q equal to right. Q equal to probability of failure equal to 1 minus p.
Sir, is it not q power n minus x?
Yeah. Q power n minus x. Out of n, if you take n successes, remaining will be failures. How many failures? N minus x. Okay. I agree. Okay. So that is the probability mass function for the binomial distribution. Okay. So you please remember it as a formula. Okay. So probability that x takes x number of successes is equal to f of x is equal to ncx p power x q power n minus x. What are the possible values of x? X equal to 0, 1, 2, and so on,
2, and so on.
and so on, and so on. Yeah. Okay. Now, how do you define cumulative probability distribution? Capital F of x. What do you mean by capital F of x? Probability that x less than or equal to x. That means what? Sum of the probabilities up to x. That means f of 0 plus f of 1 plus and so on up to what? Plus f of x.
F of n.
F of x, sum of the probabilities up to x. If you write up to f of n, then sum of the probabilities will be 1. Because for any probability distribution, all probability sum will be 1. Do you agree?
Yes, sir.
Cumulative probability is sum of the probabilities up to x. So how can I write this in sigma notation? Sigma x, I should not write x, x is fixed. Okay, let us take some, let us say from t equal to 0 to x, f of t. Okay, now what do you mean by f of t? Sigma t equal to 0 to x, f of t is binomial of t number of successes out of n trials with probability of each success is p. So this is nothing but t equal to 0 to x. Okay, t equal to 0 to x, nct p power t q power n minus t. Is it okay?
Yes, sir.
Shall I proceed? Please note down. Shall I proceed?
Yes, sir.
Yes, sir.
Now,
Yes,
suppose
sir.
if I want probability that x equal to x, which is nothing but f of x. Can you get this through cumulative probability? Capital F of x minus capital F of x minus 1. Am I right? Sum of x successes minus sum of x minus 1 successes equal to probability that x equal to x. This is small x. So capital F of x minus capital F of x minus 1. See, what is f of 4? What is f of 3? F of 2 is, I can write it as capital F of, let us say f of 3. F of 3 is a capital F of 3 minus f of 2. What do you mean by f of 3? F of 1 plus f of 2 plus
F of 3
minus
minus
f of 1
1.
f of 2. So if I cancel out f of 1 f of 1 f of 2 f of 2, what is remaining?
F of 3.
So you can get this probability value through cumulative probabilities also. Do you agree? You can get the probability value through cumulative probabilities.
Yes, sir.
Okay. So now if you realize this point, now I can use this cumulative distribution table, whatever I shared now in WhatsApp, that I can use. Okay. Please note down this point. Write this as a fourth point. Shall I proceed?
Yes, sir.
Okay. Now suppose that let us say I want probability that 2 less than, okay, so 2 less than or equal to x less than or equal to 6. Let us say n equal to 5 with the probability of each success equal to, let us say, 0.5. What do you mean by this actually? Can you tell me? Probability that
F of 2.
probability that x equal to 2 plus probability that
It's
x
equal
equal
to
to
3.
3 and so on plus
5, 6.
probability that x equal to 6. It will take some time. Am I right? And what is this? This is nothing but f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6. Or I can write it as sigma x equal to 0 to, sorry, x equal to what? From where to where?
2.
Yes, x
2
equal
to
to
2 to
x equal to 2 to 6. Okay. F of x, or I can write it as sigma x equal to 2 to 6. Okay. Binomial of x number of successes out of 6 trials with probability of each success is 0.5. Or I can write it as x equal to 2 to 6, 6c2, 6cx. Okay. P. What do you mean by P? Let us for the time being call it as 0.4. 0.4. Okay. So 0.4 whole power x, and what will be Q? 0.6 whole power 6 minus
6.
x. Is that okay? So 6 probabilities you have to find. How many? Sorry. 1, 2, 3,
5.
4, 5 probabilities you have to find. Five probabilities you have to find. Where is this? Gone?
I think that's
Gone. Something happened. Color changed or what? There is no undo here. Okay, at least okay. Okay, I will look into this later. So you have to find out 5 probabilities. So what I was telling, if you want to find out probability that 2 less than or equal to x less than or equal to 5, you have to find out 5 probabilities x equal to 2 to 5. Sorry.
6.
2 to 6.
2 to 6.
I wrote 2 to 6. Huh?
Yes, sir.
Yes, sir. Yes, sir.
Okay, 2 to 6. 2 to 6 binomial of x number of 6. How many trials I wrote?
5 trials.
Huh?
5 trials.
I think
Five.
5 trials is not possible, right? Because I wrote 6 here. Okay, so n n must be more than that. Okay, so let me say 8, n equal to 8. Okay, out of n trials with the probability of each success is 0.4. So I am assuming that p equal to 0.4. So you have to find out 2, 3, 4, 5, 6, 5 probabilities and add some. That is one way. I agree. Okay, you just use your calculator. Just use your calculator and find out the answer. But what is the other way of doing this using a cumulative probability? How do you find out this 2 less than or equal to x less than or equal to 6 in terms of cumulative probability? Can you tell me?
F of 6 minus F of
F
1.
of 6 minus f of 6 minus
F of 1.
f of 1, because 2 is also included. 2 is also included. I said for a discrete probability distribution, whether you are including the endpoints or not, it matters. Okay, so f of 6 is sum of 6 probabilities. Okay, f of 1 is x equal to 1 probability. So if you take 1 from 6, it will remain from 2 to 6. It will remain from 2 to 6. Okay, now I can simply look at this binomial distribution table. Okay, please remember these values. N equal to 8. I said n equal to 8. Okay, so let me show you this. Now where is n equal to 8? Are you able to see this? Horizontal values are p values. Horizontal values are p values. See, this is cumulative probability distribution. See, probability that x less than or equal to x is a cumulative probability distribution. I used t, here he used r. Can you see that? Okay, so n equal to 8 you see here. You find out n equal to 8 here. N equal to 8 is here. And what is probability of success? I said probability of success is 0.4. I said. How many successes you want? F of 6. Am I right? So you look at say here x equal to 6. See here in this row, you look at here 0.9915.
991.
Are you able to see this 0.9915? You
Yes,
don't know,
sir.
you don't need to use the calculator. You just look at this binomial distribution table and copy this value. Okay, so this is 0.9915. So this is by 0.9915 minus f of 1 for this n value, for this p value. Okay, now I want f of 1. So where is f of 1? Okay, now you look at here x equal to 1 for 8, 0.4. Can you see this value? 0.1064. Am I right?
Yes, sir. 0.1064.
So 0.1064. So subtract this and tell me the value.
0.8851.
0.8851.
I1.
You agree? So you can use your calculator and find out the binomial each individual binomial probability and take the sum. The otherwise using the binomial distribution table, cumulative binomial distribution table. Okay. So what I'm telling, even if you use this, even if you calculate these individual values, so you will be getting 0.8851 only. If you want, you can verify this. Okay. Similarly, can you tell me if I want only probability that 2 less than x less than or equal to 6?
Yes.
F of 6 minus
F of 2.
f of 2, because it is starting from 3. Similarly, 2 less than x less than 6. It is taking 3, 4, 5. It is taking only 3, 4, 5.
F of 5 minus F of 2.
F of 5 minus, see, less than or equals to, you see. Okay. So it is taking 3, 4, 5. 3, 4, 5. That means F of 5 minus F of 2. Similarly, what is the last one? Probability that 2 less than or equal to x less than 6. It is going to be F of 5 minus
F of 1.
F of 1. Is that okay?
Yes, sir.
Okay, so that is how you can do the problems. Okay, so by using your calculator, you can find out the individual binomial probabilities and add those values, or you can use your distribution table. You can use your distribution table and copy the values and simplify. Is it okay? Now we may be interested in finding the attributes of this binomial random variable. What attributes we have seen earlier? Statistical attributes: mean, variance,
Mean, variance, and
Standard
deviation.
and standard deviation, right? So what is the other name for mean?
Expectation.
Expectation.
Expectation. So expectation or
Expectation.
average or mean. Okay, so we shall find out that now. Okay, so put this side heading: attributes on binomial random variable. Attributes on the binomial random variable. Okay, so what is the first one? Mean, or you instead of mean we always call it as expectation. Okay, so first one is I think this is not working. So okay, so what is the first one? Expectation, right? Expectation or mean of a BRV. What do you mean by BRV? Binomial
Binomial.
binomial random variable. Okay, so how do we, what is the formula for the expectation? What is the definition of expectation? Expectation of x equal to, should I use sigma or integration?
Sigma.
Sigma.
Sigma x into f of x. Am I right? What are the possible values of x for a binomial random variable?
0 to
0
n.
0 to n.
Go to n.
So this is sigma x equal to 0 to n x into binomial of x number of successes out of n trials with probability of each success equal to p. So what is its formula now? Summation x equal to 0 to n x into, what is the formula? What is the probability distribution for binomial distribution? NCX
NCH.
p power x
P power X.
q power n.
Q power
Okay,
minus
so
X.
you keep writing your notes also. So I can write it as a summation x equal to 0 to n x into NCX formula n factorial by x factorial into n minus x
N
factorial
minus.
into p power x q power n minus x. Okay, so this is equal to summation x equal to 0 to n x into, if I take n, remaining would be n minus 1 factorial. Am I right? Divided by, if I take x here, remaining will be x minus 1 factorial into n minus 6 factorial. And if I take p from here, e power x minus 1 q power n minus x. Okay, so what do I do? So I can cancel out x and x here. Okay, so now you take out this n and p outside, n and p outside, summation. Okay, so what is remaining? N minus 1 factorial by x minus 1 factorial into n minus x factorial into p power x minus 1 q power n minus x. Can you tell me x values from? Denominator x minus 1 factorial. Denominator x minus 1 factorial means x has to start from
1.
1 to n.
1, 2.
1 to n. Shall I proceed?
Yes, sir.
Okay. Now I'm writing in the next step. What is this? This is all about expectation, right? Okay. So keyboard not working, that's the problem. So I'm continuing the calculations. X equal to so I was trying to find out expectation of x. So which is equal to sigma x into f of x, I said. So what is the continuation step?
NP
NP
into
summation of
summation
NP into summation x
sigma.
equal to 1 to n minus 1,
Yeah.
1 to n, 1 to n. Tell me.
n minus 1
N
factor.
N minus 1
factorial.
factorial by x minus 1 factorial
X
into
minus 1 factorial into n minus x factorial.
n minus x factorial into p power x minus 1 q
Minus 1
power n minus
power
x. Okay. Now you just take some substitution. Let us say take x minus 1 equal to, let us say, y. X minus 1 equal to y. Then what will be this this one? Np into. So when x equal to 1, what will be y value?
0.
0. So y varies from 0 to. So when x equal to n, what will be y value?
N minus 1.
Minus
N
1.
minus 1. Okay. So then this n minus 1 factorial by what will be x minus 1? Y factorial.
Factorial.
And can I write this as when I replace x with y plus 1, can I write this as n minus 1 minus y?
Yes, sir.
P power, what is x minus 1? Y. Can I write this n minus x as q power n minus 1 minus y?
Yes, sir.
Yes, sir.
Okay. Now can you identify this one? For the time being, call n minus 1 equal to m. Np into y power y equal to 0 to m factorial by y factorial into m minus y factorial into p power y into q power m minus y. Can you identify this?
MCY.
MCY into
This is nothing but a p plus q whole power m. Do you agree on that? Binomial theorem. Each term is a binomial term, no? And what is p plus q? Q equal to what? 1 minus p. P plus q equal to 1. So this is 1 power m, which is np. So from this, what is your understanding? Expectation of Therefore, expectation of the binomial random variable. Expectation of the binomial random variable equal to mu equal to NP. Right now. Okay. Expectation of a binomial random variable is NP. Mean of a binomial random variable is NP. Shall I proceed?
Yes, sir.
Okay. So similarly, you please find out variance also. With that, we'll stop the class. So put the side heading variance of the binomial random variable. Variance of the binomial random variable. So what is the variance formula?
E of x square minus E of
X
x
square
whole
minus E of x whole square.
Variance equal to variance of x equal to expectation of original definition is x minus mu whole square.
Yeah.
But I can write it as E of x square minus E of x whole square. Am I right? Now E of x square minus what is E of x now? NP. NP whole square.
Hmm.
Now what is E of x square? Sigma x square into
x square.
f of x minus n square p square. Okay. Okay. Now add and subtract x. What are the possible values of x? 0 to n. X square minus x plus x. You add and subtract x. Okay. Into f of x. Okay. Minus n square p square. Put a bracket, otherwise it will misinterpret. So this is if you take x common, what do you get? This can be written as x equal to 0 to n x into x minus 1 into f of x. I'm grouping these two terms. Plus sigma x into f of x. This one x into f of x. Okay. Minus n square p square. Am I right? Now what is sigma x into f of x?
E of x.
E of x. So which is np? So this is summation x equal to 0 to n x into x minus 1 into f of x means what? Binomial of x number of successes out of n trials with probability of each success is p plus np minus n square p square. Okay. Now I just have to simplify the first term and get the answer. So this is x into x minus 1 into what is this binomial formula? NCX into p power x q power n minus x q power n minus x. Okay, with the limits from np minus n square p square. Okay, now apply the binomial formula and simplify this. Summation x into x minus 1 into n factorial by n minus x factorial into x factorial into p power x into q power n minus x. X varies from 0 to n plus np minus n square p square. Now, which one we shall take from n factorial?
N into n minus 1
N
into n minus 2 whole square.
Right. So n into n minus 1 I will take out. What is remaining? N minus 2
N minus 2
factorial.
whole.
N minus 2 factorial, and from p power x I will take p square. So what is remaining? P power x minus 2 into q power n minus x divided by, and here x factorial I will write it as x into x minus 1 into x minus 2 factorial into n minus x factorial plus np minus n square p square. Here x equal to 0 to n. So after cancelling the terms, can I write? So if I take this part, n into n minus 1 into p square, if I remove, then what is remaining? X into x minus 1 x into x minus 1 I can cancel out. So what will be remaining? N minus 2 factorial by, okay, x minus 2 x minus 2 factorial into n minus x factorial into p power x minus 2 q power n minus x. With x varies from where to where? 2 to n plus np minus n square p square. Np minus n square p square. Is this clear?
Yes, sir.
Yes, sir.
I think I took only p square common, no? So similar to the previous case, if I take x minus 2 equal to y and do some manipulations, what do I get?
Summation of
p plus q whole power n minus 2. Do you agree? Did you copy these steps?
Yes.
Did you copy these steps?
Yes, sir.
Okay, so if I can write here, so you just check whether this is a q plus p whole power n minus p or not. So this is n into, so I can write it as n square minus n into p square. This is going to be, so if you take x minus 2 equal to y and do all these things, you will see that this is going to be p plus q whole power n minus 2 plus np minus n square p square. So what is the simplification? P plus q is 1, 1 power n minus 2 is 1. So this is n square p square minus np square plus np minus n square p square. N square p square gets cancelled. So if I take np common, what is remaining? 1 minus p. What is 1 minus p?
Q.
Q. So from this, what is your understanding? Variance of binomial random variable is npq. Variance of binomial random variable is npq. What will be standard deviation?
Under root NPQ.
Under root of
Square
npq.
root.
Square root of npq. Okay. So please note down this. So problems on this we will do into my next class. Okay. So in today's class, we understood what do you mean by Bernoulli's process or Bernoulli's experiment, and we have defined binomial random variable. Binomial random variable is nothing but x equal to number of successes out of n trials in a Bernoulli's experiment, and we have seen its probability distribution. Probability that x equal to ncx p power x q power n minus x, and we have defined cumulative probability distribution, and we have seen this cumulative probability distribution table, and we have seen how to compute these probabilities using this cumulative probabilities. Okay, later we computed expectation and variance of the binomial random variable. Okay, so this today's class was very important. So whatever I discussed today, you just okay, update the notes and revise. Okay, revise once. You practice the proofs of this expectation and variance of a binomial random variable. Mean of a binomial random variable is NP. Variance is NPQ. Standard deviation is root of NPQ. Okay. So next class will be on Monday. Okay. Next class will be on Monday, and on Sunday, by Sunday, see that you uploaded all your notes in the PDF format as you did earlier. Okay. Is this clear to all of you?
Yes, sir.
Yes, sir.
Okay.
Sir.
So please revise the notes.